our EMEA division of cloud practice, and Tushar Agarwal, who heads the Asia Pac practice for cloud practice, and myself, Marinder Bhogal. I had the North America practice for GlobalLogic cloud practice. So without any further ado, I'll hand it off to Andriy, and he can walk you through our OpeNgine Accelerator for GCP and how it can help to make a good accelerator for Google. Andriy, all yours, please.
Hello, everybody. Let's start our presentation of OpeNgine Accelerator for GCP, and I will start with the introduction, which is about why we actually do it and what is the place for this accelerator. So the GlobalLogic as a company together with Google is providing our customers with various services. So that's implementation, development of the solutions. And those services are usually include DevOps as a several different offerings. But as we've got a lot of experience with our customers, we as a company developing now accelerator, which accumulates and is based on our experience, and the target is to provide our customers with solution which can accelerate implementation of cloud platform, which can accelerate the kickoff of the projects for the teams, and which is based on the best practices. So usually what we provide several types of services, and so it can be advisories, it can be the service when we go to customer and we investigate what happens, we check and ask questions, and we provide our customers with some advisory or the plan or design architecture how to implement certain things. It can be on solution on demand, service on CI/CD on or DevOps on demand, when we just provide our resources. But the most interesting option is the OpeNgine framework. That's the accelerator which basically speed up the process of cloud adoption using Kubernetes, managed Kubernetes services on Google Cloud. And so what is OpeNgine? What kind of subsystems and components it includes? So that's support for multi-cloud solutions, and we also incorporate the subsystem which actually automates deployment and orchestration of your containerized workloads. That's of course automated configuration and provisioning of all needed tools, including virtual networks on the Google Cloud platform, and including clusters, and including, of course, all tools needed to provide operations support, to support you with in terms of security and governance. And in addition to that, we providing our customers with professional services and support and managed services. And so it can be extended. It can the framework can be extended new features can be introduced by request of from customer side. And we of course have the roadmap of features for the nearest several months, but we are always open to discuss and prioritize and accelerate some of the features in our roadmap if our customer asks about this. So for current implementation is in current version we mostly focused on day 0 and day 1 operations, but in our roadmap we have a rich set of functionalities to simplify and to automate day 2 operations too. So who can use what kind of customers might be interested in OpenEngine? So that's of course those customers who want to modernize their applications, who want to do certain developments from scratch, and of course that's applications which are based on containers, and Kubernetes we see as a core part of the solution in this case. So it can be very interesting for they want to quickly spin up the sandbox to develop their solutions or to do proof of concept, to do certain testing activities, and if you need to do some quick evaluation, the OpenEngine will provide you with the ability to spin up such environments in very short time period. So that could be a real competitive advantage. So sometimes there is a lack of deep experience in terms of infrastructure, in terms of configuration, and in this case OpenEngine can also help, because the system which is automated end-to-end and is based on very simple YAML configuration file, it allowed to start adoption of the cloud technologies, even if the experience is still very little. So you can start and you can learn in parallel. You will not need too much experience in low-level details, because those are available, of course, but it can be hidden, and you can just rely on some pre-configured templates to spin up your environment. So yeah, of course, that's mainly targeted for the companies and teams who want to adopt a new strategy for cloud native applications. So sometimes you need to quickly evaluate and compare how your solution works, for example, in private cloud or in Google Cloud, and you can do it by provisioning exactly the same structure of environment, exactly the same set of tools will be deployed in 2 different environments. So you can put your software in both and compare, and you can make multi-cloud setups to solve certain technical challenges. So Yeah, as I said, what are the benefits or key value propositions in the OpeNgine framework? So that's of course the combination of best practices which are incorporated into scripted, automated provisioning of the environment and configuration of the tools. So mainly, so we are using open source tools and we are using native Google Cloud services. So you can interchange them, you can mix and match. You can use them together, or you can choose just platform tools, and that's another advantage. We provide templatized configurations for most typical scenarios, and that's not only about environment, but that's also about CI/CD pipelines for different languages, for different stacks. So I think the most interesting value here is the speed up of adoption. So instead of doing it by yourself during weeks or months, you can just do it during days or even hours. And our target and is to make sure that even small team, even without big DevOps stuff on board, you still can have full DevOps lifecycle implemented, including all best practices like code quality checks, security checks, blue-green deployments, and many other features. So if we take a look at the OpeNgine from the very high level, we can see that the framework consists of several modules or subsystems. For example, lifecycle management or cloud platform support and operations support. So those components can be deployed, or you can opt out. You can choose how exactly it's deployed, to which cluster certain tool goes, and you can choose Google Cloud native service for certain task, or you can choose open source software to be deployed on top of Google Kubernetes engine. In addition to that, we have environment templates. That's typical structures like dev, test, and staging environments configured as three dedicated clusters. And you can have dedicated management cluster, which basically runs all software needed to collect logs, do monitoring, perform builds and integration of the software and the deployment tasks. Or you can have it as a tiny, very small environment, everything in one cluster for very small team, very small package of the software, low cost, and made as a single Google Kubernetes engine instance, running everything in one place. In addition to that, we have pipeline templates which define typical CI/CD flow, and those pipelines, they have hooks for tools which are already deployed, such as code quality checks or deployment services such as Helm, for example. And yeah, as I mentioned before, we provide professional services, managed services, and support in addition to that. and that's an extension. You can buy new features. You can ask us to prioritize certain features. So how exactly OpenEngine may look like or can look like with certain configuration on top of the Google Cloud. So in this case, we have 4 GKE clusters, and we have one cluster for development environment and a second cluster for test environment, and third is for production. And at the same time, we have management cluster, which basically is the dedicated environment for the set of management tools. And OpenEngine itself, as you can see on the left side, that's the set of Ansible and Terraform scripts which are using YAML configuration to provision all those environments in one run. So you can see that the tool takes configuration, and as a result, you have this environment up and running, configured to have intercommunications between clusters, and the certain set of managed services such as a cloud build, container registry, or cloud KMS, they are also configured to be used by your software, by CI/CD pipeline, and to allow you to build or store your images, or to make sure that your data is secure and encrypted. So we can take a look at certain parts of the system to represent what kind of options we can provide and how exactly we are integrating with the Google Cloud services. Let's look at one of the examples. So we have HashiCorp Vault as a unified interface and unified application to store secrets, not only for management tools, but we also providing it as an option for application clusters. And we basically can have 2 options and 2 different types of integrations with Google Cloud services. So the first option is at the left side. In this case, we are using console as a storage, and the console basically is using persistent volumes. And we are using cloud KMS provided by Google Cloud to unseal HashiCorp Vault, and to make sure that the Vault is using best practices to encrypt data and to refresh keys. And this is automated. It works just silently creating the proper configuration. So applications can communicate to Vault and store and get the data. At the right side, you can see a bit different option. In this case, the console is not used, and Vault is using cloud storage buckets to keep the data. But in this case, the cloud KMS is still in use and ensures that the proper key is used to encrypt the data. Let's move on. And there is very interesting part of the OpenEngine. Basically, we are setting up service mesh using our automation. And using service mesh, we actually do several things. So first of all, we provide ability to communicate between multiple clusters. So we provide visibility for management tools. We provide visibility for agents like FluentD, for example. So FluentD can actually collect logs, collect information and store it into the central location. And you can use the management cluster as a single point of control over your environment. Also, we are using namespaces together with Istio to ensure that to apply network policies and prevent communication, unintended communication between services. So we are doing micro-segmentation of our application, and we provide the same for the application. So if you put your application here, you can use Istio already, and you can utilize all features available for Istio. Also, we have a special broker. In this case, that's DEX software, which is the broker for authentication. And through the DEX, you can integrate to external identity service, identity management system. And basically, you can use your LDAP or your Google identity system, or you can use some other identity providers to authenticate your users to services in the environment. So that's the idea of networking and the structure, how services are communicating to each other. And again, that's what we do as a single run of execution based on the configuration file. Another very interesting example of integration with Google Cloud Platform is actually ability to use Cloud Build and Google Container Registry and GKey to set up CI/CD automation. So you can have pipelines defined using simple configuration definition and provisioned automatically by OpeNgine, connected end-to-end and set up to build your code and to deploy it into the provisioned environments. So in this case, there are several stages and actions performed by OpeNgine automation software. So we have Terraform and Ansible scripts which take YAML config file and provision networking and Kubernetes engine cluster or clusters. Then using information defined in the configuration file, we provision or we reference existing container registry. Then we take actually in configuration file there is a reference to repository for specific microservice, and in this repository there are 3 parts which we provide as a templates. That's pipeline template, that's Dockerfile template, and that's Helm chart template created for different types of application or different stacks like .NET Core or Java or Node.js, for example. So what OpeNgine does, it takes this reference to repository, and then it uses it to create the trigger in the cloud build, and it supplies it with all needed information. So basically the template is supplied with all needed parameters, all needed values, such as references to secrets, references to certain clusters, and specific namespaces or specific applications. So in this case, as a result, after execution of this automation, we have the cloud build trigger defined, which monitors the microservice repository for a specific branch in it for changes, and then the build is triggered, and the build basically performs multiple steps multiple steps, and so we are using Dockerfile as an abstraction for build process. So multi-stage Dockerfile is used to build and to package the application code into containers, and we are using Helm chart to execute deployment of the service to target environment. So yeah, as I mentioned before, one of the very interesting features is actually templates in OpeNgine, and there are two types of, or two families of templates. So one family is the environment templates, which define how many clusters you need, what kind of clusters you have, is your management tools mixed or collocated with your development environment in single cluster, or it's dedicated. So we have several of those defined already, and so we can use them as a kickstart for POC deployments for our customers, for some pilot adoptions, and then of course they can be customized, extended, and tailored for customer needs. So another type of pipeline of templates, that's the templates for the CI/CD pipelines, and here we have multiple options, what kind of template it can be, what kind of steps it can include. But the general idea is that the template is made to be compatible with the tool set we are using, and so engine can, OpeNgine during provisioning and at the runtime can supply all needed information, all environment variables or references or secret values to be extracted from the vault storage. So in this case, the template becomes the real pipeline which executes and perform actions like code static analysis or scanning for some license violations, or performs search for certain security problems, or in other words, that's part of the solution, and basically provides unlimited possibilities for customization and ability to simplify the process of adoption. So OpenEngine actually it includes certain activities automated for day 1 and day 0, day 1 and day 2, and certain activities are still performed as a manual operations. For example, when you start deployment, there is a certain expectations of from the Google Cloud. So you have to have account and the project, and you need to make a service account and supply it with grant specific set of roles to this account, so it can be used to provision the entire environment. So for now, this part is documented, and that's manual part as a prerequisite, but we are working to make it even more attractive, even more automated, so you will not need even those actions to be performed manually, and such actions will be done by the software as well. So we have CI/CD pipeline for each microservices. We have service mesh rules and configuration for secrets management, and we are flexible in terms of branching strategy. In this case, we can support different approaches which are more familiar to the team and already adopted at customer. The day 2 operations, we support several scenarios like upgrades of the software, monitoring and alerting, and security checks for the software that's already implemented and provided as a part of the solution. But at the same time, we are flexible to introduce certain aspects of day 2 operations into the solution, and we can speed up our roadmap in case of specific interest from our customers. So, for example, there are multiple possible use cases of the OpenEngine, and that's one of the examples which is very attractive for modern software development teams. As you know, machine learning solutions are now very, very popular, and they also require, of course, standardized approach to organize the development process, automation, and CI/CD pipeline for machine learning should be in place as well, not only for Java code, but also for machine learning stuff. So in this case, as an example, here is the high-level structure of the solution when the OpenEngine is used together with several open source tools such as Kubeflow and MLflow. So those tools are deployed and configured together with the core part of the OpenEngine, and provide end-to-end automation for the machine learning CI/CD. So in this case, it can be seen as an extension of certain machine learning features of the Google Cloud to on-premise, or the ability to run development environment and then deploy your machine learning models to Google Cloud AI platform, as a result to execute them on your cloud infrastructure, or directly, or to execute them inside the software as a service or platform, AI platform provided by Google Cloud. So that's most of the information I wanted to provide and describe. Let me quickly show you. For example, here we have definition of several artifacts in our configuration file, such as a Docker repository. We have we have Git repository definition, and then we have certain parameters for the cloud build. And when we execute the provisioning, we have in our environment, we will have first of all, we will have 2 clusters with set of services running on those. So if you look at typical management cluster, we will see that it's already running set of services such as a Grafana, Kibana, FluentD, and SonarQube, and they are deployed here and configured. If we go to Cloud Build and we'll take a look at the trigger definition, we can see that, for example, here there is a definition of specific parameters, variables specific to this certain specific environment, and that's the automation tool which does creation of this trigger and supplies all needed names and values. Of course, we are not exposing anything which should not be exposed. All secrets are kept in the vault and retrieved by the build engine using corresponding permissions, and so the data is secure. And if you look at the typical pipeline, so here we have several steps that's built using Docker build. So we are using multi-stage builds, and we produce Docker image as a result, which is pushed to the repository, and then we use Helm to deploy the service to corresponding environment. So that's an example I wanted to show, and I think we now can switch to questions Q&A session.
One of the questions from Mahadev is, in the CI/CD pipeline, where do we get the build tool?
Yeah, so build tool is defined inside the Docker file. So that allows us to abstract from specifics of the build. So, for example, you have Maven or Gradle, or you have Microsoft build, or something else, or I mean .NET Core build. In this case, all this specific is included into Docker file. So we are using multi-stage Docker file, which first takes base image with the build tool and executes the build. Then the base image is switched to the target base image, Alpine or some other. Depends on what kind of base image you plan to use for your software. So then the results of the build is copied, so you make a new image, and that's the result of the Docker build execution. Thank you. Any other questions?
There was a question around, are there any templates for AWS, or is this specific to GCP only?
Well, we have actually our system is flexible enough to support multiple platforms. So as soon as we provision Kubernetes cluster, then certain set of software is set up on top of it. So we are using Helm and Kubernetes provider for Terraform, and that allows us to be flexible and compatible. So yeah, yes, we have automation to provision Kubernetes clusters on-premise and on other cloud platforms as well, not only on Google.
Guys, if there are any other questions, you can just type them in the window and we can try to answer them. So the question is, are the Git repos accessible to other folks?
No, this Git repository is internal, so it's not yet made open source to external users. So for now, we are providing access to our customers during the implementation process, and that's the model for now. In future, that's discussable, and we are considering different plans or different options. So probably at some point it may become open source completely, but not now, not yet.
Shikhar, I think the question was internal access from within GlobalLogic, that we can probably take offline.
Yeah, internal access, yeah, we can organize that. You definitely can reach this documentation, so that can provide you with certain information, more details, more information about how it works, what is the configuration definition, what is the structure of the solution.
Any other question, guys? Okay, so I guess that is it. So thank you for everybody for joining. What we will try to do is put this recording online after this session, and I hope that we are all able to learn something new. And in case there are any follow-up questions, you can reach us at the email ID shown on the screen, and we would be happy to answer any questions that you might have. Thanks
Thank you
everybody
very
for
much.
joining.
Thank you, everybody.
Thank you very
Thanks,
much.
Andriy.
It was a pleasure to be here and to provide this information. Thank you. Have a good day.
Thanks, Andriy. Thanks, everybody. Bye-bye.
Bye.